Well, we would hope that you know our names by now, since you're all such loyal fans, but if not, that's Steven and I'm Callie.
And I know you wrote the lab, but this is Lab 11.
Detectors with Michaela May.
Here's the experimental setup for Part A. Under this cloth we have the LED, as well as the PMT and photodiode, the O-scope to get our readings, and the generators with which we can change the LED. Here we can see the two readings from the PMT and the photodiode. The yellow is the PMT with a clear peak, and the blue is the photodiode, and there's a more aggressive peak but a lot more noise. And as we decrease amplitude, you can see that the photodiode decays into noise and the PMT still has a signal. We can observe this effect because the PMT is amplifying the signal while the photodiode is not. Here's the experimental setup for Part B. We have our power supply, our flash source, our detector, and our O-scope. Using our single recorded pulse, we can estimate that the time decay is about 750 microseconds. Using a voltage value of 14 volts and an impedance of 1 megaohm, we get a peak current of approximately 1.4 times 10 to the negative 5 amps. This was the best signal we got using the resistor. We may have saturated the O-scope, but the amplifier wasn't letting us get a better view, so this is what we had to work with, and we can see that the decay time is slightly less than it was before. Using the smaller area detector, we see a peak that is much wider, but the peak voltage is much smaller. This is the setup for Part C. Again, we have the flash lamp, but this time we're using this CDS detector connected straight to the O-scope. Comparing our results with earlier, this time we don't see any flat top on the peak. It just begins decaying immediately after it rises. Here's the experimental setup for Part D. We have the chopper speed, which we can control here. We're supplying 6 volts to the detector. There's the O-scope, and here's the soldering iron source.
In this part of the lab, we use the Pyroelectric Detector to measure and plot the voltage response as a function of chopper speed over the frequency range, and as you can see, it is decaying.
Here we can see that it does respond to my hand, so it does respond to any thermal source, including our bodies.
In this part of the setup, we use the FLIR camera with germanium lens, and then we also did it with the mirror. As the image temperature increases, so does the object temperature. In this part of the lab, as you can see, here's our math for finding sag, radius of curvature, and the focal length.
Well, that's it. Thanks.